All right, so we're going to quickly discuss scientific notation. I want to remind you what scientific notation is. You probably know it, but we're going to just do a quick little example first of what is scientific notation. It looks like this, and it's a way to write really big numbers or really small numbers so that we don't have to write everything. So, okay, so what we do when we have this 10 to the 6th, if we wanted to convert this to like a regular number that we know what to do with, we would take this 4.68 and we're going to hop 6 times with our decimal. So 1, 2, 3, 4, 5, 6, and I'm going to put all these zeros in here. Okay, so I ended up with 4 zeros, 4, 6, 8, 0, 0, 0, 0. And so I'm going to use my comma rules. Every 3, I have a comma. So this is 4,680,000. Okay. And it's way easier to write it like this. If we had a really small number, we would do kind of the same thing, except backwards. We're looking for a negative exponent. Okay. So if I had 2.6 times 10 to the negative 5, okay, I'm going to do kind of the same thing, except I'm going to go the other direction. Okay, so I'm starting with my decimal, 1, 2, 3, 4, 5. So this is where my decimal goes, and I have some zeros out here. So I have 0.00026. Okay, so that was just a quick rehash of scientific notation. If you have questions about that, you can let me know. But what we're actually doing today is multiplying with scientific notation. Okay, so let me show you how that works. So 5.67 times 10 to the 7th, okay, times 2.7 times 10 to the 4th. So what we're doing here is we're essentially kind of considering this our coefficient, okay? And we're using these for our product of powers rule, okay? So what I'm doing here is I'm taking this 5.67 times the 2.7. So let's do that first. 5.67 times 2.7 equals 15.309. All right. And then for our times 10 to the whatever, we're going to have times 10 to the 7 plus 4. Okay, so 7 plus 4, 7, that is 11. So I'm just going to kind of erase this and change it to an 11. It's a little easier to see right now. Okay, so 15.309 times 10 to the 11th. Now, one thing I didn't mention on scientific notation before, but you might have noticed, so there's always only one digit in the ones before the decimal. You'll notice this one, it has the extra digit, okay? So we want to convert this and add that exponent, okay? We're going to go this way. Okay, so now we have 1.5309. We have to think, okay, if it's already to the 11th, are we making that number bigger or are we making that smaller? And so sometimes you might not be sure. And so an easy way to figure that out, it's kind of annoying because you have to write all this stuff. Okay, so we had the 15.309. We're going to do what we did earlier. We're going to bounce 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Let's see. 1, 2, 3, 4, 5, 6, 7. How many? 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay. And so now I'm essentially going to undo that to put this 0 in the right place. 1, 2, 3, 4, 5, 6, 7, 8, blah. Okay. But I think you can kind of intuit that now our number is 1 bigger. Okay. But that's an easy way to do it if you aren't quite sure. And just know that if you're going this way, you're adding 1. All right, but always write it out if you're not sure. I have no issues with that because that'll help cement it in your brain as well. So that's an example of multiplying in scientific notation. I'm going to give one more example of that. Okay, so let's get a new problem here. I don't like this problem. Okay, this one's fine. So we have oops, I'm on eraser. 4.29 times 10 to the 5th times 9.75 times 10 to the 2nd. Okay, so 4.29 times 9.75 is 41.8275. And then I have my 10 to the 5 plus 2, which is 7. Okay. But I still have to convert that. So I'm going to do that just the same way I did before. 4.18275 times 10. And I'm adding one extra decimal there. Okay. So I hope that helps. Let me know if you have any questions about scientific notation.